with our study of vectors by solving more problems using vectors. Alright, two velocity vectors v1 and v2 when added together gives a resultant v3 equal to 2 meter per second I minus 1.5 meter per second j. If v1 is 4 meter per second I minus 3 meter per second j, what is v2 in magnitude angle form? Well, you need to understand this question well in order to do this. What is given here is v3. v3 is the sum of v1 and v2. You are also given v2 and you are told to find v1. Is that right? So we know that v3 equal to v1 plus v2. We know v3, we know v1, therefore v2 will be v3 minus v1. That means you can obtain the x component of v2 by subtracting the x component of v1 from the x component of v3. In other words, the x component of v2 will be 2 meter per second I minus 4 meter per second I. This is the x component of v3. Subtract the x component of v1. That will give you the x component of v2. And the y component of v2 will be the y component of v3 minus the y component of v1. Alright, let's do that. Now v3 equal to v1 plus v2, and that v3 is 2 meter per second I minus 1.5 meter per second j. And v1 is 4 meter per second I minus 3 meter per second j. Therefore, now this is your v3, this is your v1, therefore v2 will be v3 minus v1. So we subtract the I components first and then the j components. So the x component of v3 minus the x component of v1 will give you the x component of v2. The y component of v3 minus the y component of v1 will give you the y component of v2. So that will be 2 meter per second minus 4 meter per second I. This is the x component of v2 plus negative 1.5 meter per second minus negative 3 meter per second j. This quantity minus this quantity of j. Alright, that will be 2 meter per second minus 4 meter per second is negative 2 meter per second I, and this double negative will become positive. So this will be 3 meter per second minus 1.5 meter per second, that is positive 1.5 meter per second j. So we obtained the vector v2 in terms of its x and y components. Well, now we need to obtain the magnitude and angle. If you know the x and y components, how would you obtain the magnitude of the vector? Magnitude of v2 will be square root of x squared plus y squared. Right? This is the x component, negative 2 meter per second. This is the y component, 1.5 meter per second. Therefore, the vector v2 will be this vector. The magnitude of v2 is square root of x squared plus y squared. and that will be 2.5 meter per second. This is your vector v2. So v2 equal to 2.5 meter per second is the magnitude. We now need to find the angle of vector v2. Now you should understand that the positive x-axis is that way. So the angle is this angle. But you can now find this angle by using the opposite side and the adjacent side. Alright, if this is the angle theta, you don't need to say that this is the angle. The angle is actually this obtuse angle. And that obtuse angle is such that its opposite side is 1.5 and the adjacent side is -2. Is that right? Therefore, the direction of v2 is given by this angle theta with the x-axis. So tan theta equal to y divided by x. Y is 1.5, x is -2. So tan theta is 1.5 divided by -2. You see that negative sign is very important there. This tells me that the y value is positive, the x value is negative, therefore the angle is a second quadrant angle. That information is very important for you. Now, this tan theta is, if you put this in your calculator, can you now do that? Tan inverse of 1.5 divided by -2. What does that give you? Tan inverse of 1.5 divided by -2 will give you -37 degrees. Now, those who understand inverse functions, you know that tan inverse is defined only in the fourth quadrant and the first quadrant. So, the calculator gave you a fourth quadrant angle. Tan inverse of 1.5 over -2, the calculator gives you -37 degrees. Is that wrong? Well, actually no. It is this angle that the calculator gave you. You see, let me draw that for you. The calculator gave you this angle. There you are. This is the angle -37 degrees. Now remember, an angle measured from the x-axis in the clockwise direction is negative. Now, what we need is this angle. And if you notice, all you need to do is to get the second quadrant angle, add 180 to -37. So -37 plus 180 will give you this angle theta. So this is the fourth quadrant angle. There you are. Now, since the x component of v2 is negative and the y component is positive, you must know that the angle theta is in the second quadrant. Oh, the angle theta is in the second quadrant, not the third quadrant. So please change this into the second quadrant. This is a second quadrant angle. Is that right? Let's draw those quadrants there. If this is the quadrant, this is the first quadrant, that's the second quadrant. So the angle theta is a second quadrant angle. And how do you obtain that second quadrant angle? Add 180 to -37. So theta equal to 180 plus -37, which is 180 minus 37. That is 143 degrees is that angle. Alright? Now, situations like this are very common in adding vectors. Now, you must know what quadrant the angle falls, and therefore what will you do to get that angle. Do not always depend on the calculator. The calculator will obey strictly the mathematical rule, because tan inverse is defined only in the first and fourth quadrant. If you are looking for a second quadrant or third quadrant angle, the calculator will not give it to you directly. You need to do this manipulation to get that angle. Okay, let's do another problem. A particle's position coordinates xy are 2 meter, 1 meter at t equal to 0 and 8 meter, 5 meter at t equal to 5 seconds. Find V average, average velocity from t equal to 0 to t equal to 5 seconds. What is the definition of average velocity? Average velocity is the rate of change of position. Now, what is significant here that you notice? The position, the x position of the object has changed. You see, originally the object is at x equal to 2. It changed to x equal to 8. So its x position has changed. Also, its y position has changed. Initial y position is 1 meter. The final y position is 5 meter. That means there is a change in the x position. There is a change in the y position. Therefore, you need to calculate the average velocity in the x direction and then calculate the average velocity in the y direction. Is that right? Because our initial definition of average velocity, this is what we did. V average is delta x divided by delta t. Now, we should now understand this as the average velocity in the x direction. So we're going to call it V average x. V average x is delta x, the change in the x position divided by the change in time. And V average y will be delta y divided by delta t. You can do this problem right away here. You can see, tell me what is my delta x? What is the change in position in the x direction? It is 8 meter minus 2 meter. So that will be 8 meter minus 2 meter divided by 5, and that will be 6 over 5 meter per second I, because it is in the x direction. That is the change, that is the average velocity in the x direction. Average velocity in the y direction will be delta y divided by delta t. What is delta y? The change in the y position. It will be 5 meter minus 1 meter. That will be 5 meter minus 1 meter over 5. And that will be 4 over 5 meter per second j. So, you have an average velocity in the x direction, which is 6 over 5 meter per second I, and average velocity in the y direction, which is delta y over delta t, that is 4 over 5 meter per second j. And so, what is the average velocity? How do you write the total average velocity? I can write it as V average equal to 6 over 5 meter per second I plus 4 over 5 meter per second j. That is the average velocity of this particle during that time interval of 5 seconds. Alright, I don't know why I wrote this all down. Let's go back and look at this one more time. Alright, the initial x position is x equal to 2, y equal to 1. There it is. X equal to 2, y equal to 1. That is the initial position. And after 5 seconds, where is the object? The final position is x equal to 8, y equal to 5 is over here. So the change in the x position is delta x equal to 8 meter minus 2 meter is 6 meter I. That is the change in the x position. Delta x equal to 6 meter I. And change in the y position is delta y equal to 5 meter minus 1 meter. That will be 4 meter j. And that is for delta y equal to 4 meter j. V average in the x direction is delta x over delta t, which is 6 meter divided by 5 seconds, which is 6 over 5 meter per second I. And V average in the y direction is delta y divided by delta t, and that will be 4 meter divided by 5 second, that is 4/5 meter per second j. And therefore V average, we write it like this: 6 over 5 meter per second I plus 4 over 5 meter per second j. Alright, I want you to now find the magnitude and direction of this. I have given you, this is the component form. Convert this to magnitude angle form. Tell me, what is the magnitude of this? The magnitude of that average velocity will be square root of x squared 6 over 5 squared plus 4 over 5 squared. I'm going to leave it for you to calculate. So the magnitude of the average velocity will be square root of x squared plus y squared. And what will be the angle of the resultant, the average velocity? The angle will be tan inverse of y over x. Tan inverse of 4 over 5 divided by 6 over 5. And that will be tan inverse of 4 over 6. Alright, find that angle on your own. You can express this in terms of magnitude angle form. Okay, let's look at another problem. At t equal to 0, a particle located at the origin has a velocity of 40 meter per second at an angle theta equal to 45 degrees. At t equal to 3 seconds, the particle is at x equal to 100 meter, y equal to 80 meter, and has a velocity of 30 meter per second at an angle theta equal to 50 degrees. Calculate A, the average velocity. Well, that's not different. That is not different from what we did. It is the same thing as we did last time. And calculate the average acceleration of the particle during this interval. Well, average acceleration is delta v divided by delta t. The change in velocity divided by the change in time. The difference here is that there is a change in velocity in the x direction and a change in velocity in the y direction. Therefore, you got to obtain each of those components of the acceleration. All right. Can you draw a diagram for this? You see, if you have to do a problem well, you need to picture that problem. All right, let's draw a diagram. Where is the object at t equal to 0? At t equal to 0, the particle is located at where? At the origin. Yes, it's at 0, 0. So the particle at t equal to 0, it is at the origin, and it has a velocity of 40 meters per second directed at an angle 45 degrees. So it has a velocity 40 meters per second at an angle of 45 degrees. That means the car is moving in that direction. Well, and after 3 seconds, where is the car? It is at x equal to 100 meter, y equal to 80 meter. It is here. X equal to 100 meter, y equal to 80 meter. And at that time, what is its velocity? It has a velocity 30 meters per second. Its velocity is 30 meters per second at an angle 50 degrees. All right. So now we have all this data. This is the velocity 30 meters per second. All right. The initial position is 0I plus 0J. It's the origin. The final position is 100 meter I plus 80 meter J, and therefore what is the change in the x position? The change in the x position is delta x equal to 100 meter I minus 0, and that will be 100 meter I, and that is the change in the x position. The change in the y position is 80 meter j minus 0j, and that will be 80 meter j. What is the average velocity? Average velocity is in the x direction. The average velocity in the x direction will be delta x divided by delta t, and that is delta x is 100 meter I divided by delta t is 3 seconds. That will be 33.3 meter per second I. What is the average y velocity? Will be delta y divided by delta t, and delta y is 80 meter j divided by 3 seconds, and that will be 26.7 meter per second j. Okay? Therefore, average velocity is 33.3 meter per second I plus 26.7 meter per second j. Alright, can you find the magnitude angle form of this? I haven't done it. I'm going to ask you to do that on your own. The magnitude of this average velocity will be square root of x squared plus y squared. I hope you understand when I say x and y. This is the x component, this is the y component. So the magnitude of the resultant is square root of x squared plus y squared. And the angle of the resultant, or the average velocity, will be theta equal to tan inverse of what? Y divided by x. Okay, let's move on and do the second part. Alright, now we have the velocity. We need to find the average acceleration. Is that right? What is the velocity at t equal to 0? The velocity at t equal to 0 is 40 meters per second at an angle 45 degrees. That means you need to write that in the component form. So the initial velocity at t equal to 0, we call it v sub 0 or v0, is 40 meter per second cos 45 degrees I plus 40 meter per second sine 45 degrees J. Now use your calculator to work out those numbers. That will be 28.3 meter per second I plus 28.3 meter per second J. Well, that is the velocity at the origin. Now, what is the velocity at t equal to 3 seconds? Or we can call it v of 3. Is that right? Yes. V of 3 is at t equal to 3 seconds, its velocity is 30 meter per second at an angle 50 degrees. Therefore, the x component of that velocity is 30 meter per second cos 50 degrees I plus 30 meter per second sine 50 degrees J. And that is the component form of the velocity at t equal to 3 seconds. Again, use your calculator and find these numbers. Alright, are you working with me? Okay, that's equal to 19.3 meter per second I plus 23 meter per second J. Well, we know the velocity at t equal to 0. We know the velocity at t equal to 3. We can now find the change in velocity. But the change in velocity, there is a change in velocity in the x direction and a change in velocity in the y direction. Alright, let's do that now. Delta Vx, what does delta Vx stands for? The change in the x velocity. The change in the x velocity will be the final x velocity minus the initial x velocity will be 19.3 minus 28.3 I. That will be negative 9 meter per second I. That is the change in the x velocity. Alright, what is the change in the y velocity? The change in the y velocity will be the final y velocity minus the initial y velocity. 23 meter per second J minus 28.3 meter per second J, and that is negative 5.5 meter per second J. That is the change in velocity in the y direction. Now that means there is a change in velocity in the x direction. You can use this to find the acceleration in the x direction. So a sub x, what does a sub x stands for? Acceleration in the x direction is the change in velocity in the x direction divided by delta t, and delta Vx is negative 9 meter per second I, and delta t is 3 seconds, and so a sub x, the x component of the acceleration, is negative 3 meter per second squared I. What is ay? The average acceleration in the y direction is delta Vy divided by delta t. What is delta Vy? Is negative 5.5 meter per second J divided by delta t, and that will be negative 1.8 meter per second squared J. Alright, so we got the x component of the acceleration, we got the y component of the acceleration, and therefore the average acceleration is negative 3 meter per second squared I minus 1.8 meter per second squared J. Okay? Alright. Let's do one more problem. I hope you can read this. At t equal to 0, a particle located at the origin has a velocity of 4 meters per second in the x direction. If it has an acceleration of 3 meters per second squared in the positive y direction, what is its speed after 3 seconds? Now, we are now coming on to motion in 2 dimensions. You see, so far, before we did the lesson on vectors, we were only concerned with motion of an object in 1 dimension, either in the x direction or in the y direction. Now we are coming on to a moving object in 2 dimensions. In other words, the x position and the y position both keep changing. There is an x velocity and a y velocity, and so on. Alright, can you picture this problem? A particle is at the origin in the beginning at t equal to 0, and it has a velocity of 4 meters per second in the x direction. That means it has no velocity in the y direction. All its velocity is in the x direction. And now it has an acceleration of 3 meters per second squared in the positive y direction. You see that? So when the object comes to the origin, if the object is now at the origin, it has an x velocity, and now it also has an acceleration in the y direction. That means it will now begin to move in the y direction as well. So how will the object move? It will move horizontally in the x direction with this velocity, 4 meters per second. Is there an acceleration in the x direction? No. So the displacement in the x direction will be simply the velocity multiplied by time. This x velocity will not change. There is no acceleration in the x direction. That means the velocity will remain a constant in the x direction. But since it has an acceleration in the y direction, it will start picking up velocity in the y direction. Alright, let me see if I can illustrate that for you. Alright, now this is the origin. Alright, now at the origin, this is the object. It has a velocity of 4 meters per second in the x direction, and it has a velocity 4 meters per second in the x direction, and it has an acceleration in the y direction. Alright, let's talk about that as we move on. Okay, now this is the position of the object at the origin at t equal to 0. Is that right? Yes. And it has a velocity 4 meters per second in the x direction, and its y velocity is 0. It has an acceleration of 3 meters per second squared in the y direction. So it has an acceleration in the y direction. Since there is no acceleration in the x direction, the x velocity remains a constant. So we say Vy after 3 seconds is Vy0 plus AT. Is that right? V equal to V0 plus AT. So in the y direction, Vy0 initially is 0. Acceleration is 3 meters per second squared. So its velocity, y velocity, after 3 seconds will be 9 meters per second j. So after 3 seconds, when the object comes here, it has a y velocity of 9 meters per second and an x velocity of 4 meters per second. See that? So the y velocity after 3 seconds is 9 meter per second. X velocity is 4 meter per second. X velocity has not changed. Velocity after 3 seconds therefore is v of 3 is 4 meter per second I plus 9 meter per second j. What is the speed of the object at that time? The speed of the object is the magnitude of this velocity. What is the magnitude of this velocity? The magnitude is square root of x squared plus y squared, and that is 9.8 meter per second. Is that right? I hope you followed the way we solved the problem. The x velocity remains a constant. Y velocity, because there is an acceleration in the y direction, y velocity increases according to the equation v equal to v0 plus at. Vy equal to vy0 plus at. Initial y velocity is 0 and the y velocity at the end of 3 seconds is 9 meter per second. Well, I think we solved enough number of problems in vectors. It's a very important section, vectors and vector addition, and I want you to go through and do all these problems. Maybe watch this lecture a couple of times. Make sure that you really understand it well. You know why? In Physics 2, we will come and use all these concepts. If any one of you will come back to do Physics 2, we will use all these concepts there. Therefore, you cannot afford to miss this concept. All right, I will stop this lesson here. I will come back with the next lesson, which is actually motion in 2 dimensions. We are going to use all these concepts in the next lesson. All right, I will see you for that in a few minutes.